Just told you you were wrong, bro. Like, relax. Anyways, I went back and was doing research on the calendars and all that stuff, right, in order to be able to facilitate a further discussion and, be more well-informed on the topic. So basically what I found, Danny, and you probably know most of this, but we were talking in here before you came in, is, in 45 BC, they instituted the Julian calendar, and they knew that the orbit of Earth around the sun in a heliocentric model did not account for a year in whole number segments of days. It was not exactly 365 days. So what they made it 365.25. But the problem with that was, is it's not exactly 365.25. It was 365.2422 or whatever it is. Insert X many decimal points. And so they were gaining, since it was a little bit too long, they were gaining about 11 minutes and 12 to 11 minutes and 15 seconds a year, depending on which reference you use. And so over time, it was building up a drift forwards on the calendar. So by the time you get to 1582, 1600 and 40 something years had passed, or 1620 something years had passed, 1626, I think. So they had gained roughly 10 days on the calendar due to the calendar imprecision. So in 1582, Pope Gregory ordered them to institute a 10-day calendar skip and institute a more precise a year marker, so that they instituted the leap year cycle that we now use, which is like every 4 years, but then there's like a century leap year, and then over the every 100 years there's a century leap year, and then every 4 century leap years you skip a leap year, and that put it back on track in order for us to have a precise year, so that now we accurately reset back to the same point in Earth's orbit. And so now that we have eliminated calendar drift, because that's simply just calendar drift, that's not a physical Earth effect, that's not any physical effect, it's just calendar imprecision. But now that we've eliminated calendar drift, and we know that our leap year cycle fixes it, and we get back to the same point in our orbit year after year, all that we have left to deal with is the precession of the equinoxes. So March 21st being the calendar day, year after year after year after year after year, March 21st is at the same point in the orbit over these long periods of time. So the only thing we have to measure over these long periods of time is the axis precession of Earth at that same point in the orbit. So if you click the arrow in your whatever simulator app in the solar system or in the sun-centered inertial frame, then when you click that arrow for the year, Earth's not going to move at all in its circuit. It's just going to twist. Its axis is going to twist. And if you twist forward 443 years, which is the time from 1582 when the Gregorian calendar was instituted until 2025 today, you'll see over that 443 years that you go forward, Earth's axis will precess about 6 degrees, which means that the equinox should not be occurring on that March 21st day, because that no longer has a 50-50 distribution of the crossover between the ecliptic and the equinoxial plane. It's like 51-49 or whatever. So you have to move Earth back 6 days in its orbit to have an equinox now. And so we should no longer be seeing the equinox on March 21st. It should now be March 15th or March 27th, whichever way it is, forward or back, which I'd have to think about it. But our equinox should have shifted by 6 days due to the precession of the equinoxes since the Gregorian calendar was instituted in 1582. And the fact is, it has not. It's still March 21st now, just like it was then.
The problem is that there are 2 different years you need to consider. One is the tropical year and the other is the sidereal year. The tropical year is the orbital period with respect to the equinoxes, and the sidereal year is with respect to stars, and they're not the same. In fact, precession is called precession of the equinoxes for a reason. It causes the equinoxes, which are 2 points in space, to shift along the ecliptic. This was first noted 22 centuries ago by Hipparchus. Nobody knew the reason why, and we don't have to worry about the reason why at all. It's just a fact that we observe this to take place. And our calendar is adjusted the way it is to follow the tropical year, because we want the seasons to repeat on a regular interval, of having March 21st roughly be the vernal equinox or March equinox every year. What happens, you noted that 6 degree drift since 1582, what that's done is it's caused the stars to shift with respect to the equinox. So if you had a star that lined up with, say, the vernal equinox in 1582, it's now 6 degrees off from that. This will mean over the seasons will remain in sync with the calendar we use, but the stars will not. I mentioned before that in another 12,000 years, Orion, which is a wintertime constellation for us in the northern hemisphere, will be a summertime constellation. Scorpius, which is a summertime constellation for us, will then be a wintertime constellation. It's a definite shift that takes place, very observable. If we kept the sidereal year, then the stars would remain fixed. Orion would always be well placed in the sky all night long in December, no matter where you are. But eventually, in 12,000 years or so, the December would coincide with the beginning of summer in the northern hemisphere. We don't like that. We prefer to keep the seasons in sync. So there is a shift of 6 degrees over the past since 1582 you're talking about, but it's a shift in where the stars are. It hasn't changed the date of where the sun is because we keep the tropical year, not the sidereal year.
Yeah, except the issue is, and your explanation of it, while we both agree that the 6 degrees is happening in the sky, the justification for it, right, the way that they claim that they know it's happening is that there is a precession of the stars with respect to the sun when we measure it from the ground. But
no, it's a precession of the stars with respect to the equinoxes.
Sure, on the day of
the equinoxes are moving through the stars.
Yeah, okay. Or the stars are moving across the sky with respect to us measuring the equinox on the ground. They're equivalent. It depends on if you're heliocentrist or a geocentrist. So what I'm pointing out is the problem is that in this definition of a year, right, I said at the beginning, in the sun-centered inertial frame, 1 year is Earth resetting back to the same place in its orbit. What you're saying is we're not defining a year as the sun resetting back to the same place in its orbit. We're defining a year as the sun resetting back to the same place it needs to be in its orbit next year for the equinox to line up with the same amount of time. So
you're exactly correct. If you're going to talk dynamics, this would be the physics of forces involved, then the sidereal year is the year you want to use. But if you're going to talk about keeping the seasons in sync, then the tropical year is the one that you want to use. If you want to get the most accurate dynamical representation, you go with sidereal year every time.
So in the solar system, in the sun-centered inertial frame, how long is a year? Is it not 365.2422 days?
If you're talking about dynamics, the forces involved, then the preferable year is the sidereal year. But that's not the one we base on our calendar. Our calendar is the tropical year.
And so the 365.2422 days is not, you're saying it is not Earth resetting back to the same place in its orbit that it was last year.
It's, again, how you define the year. Are you going to define the year in terms of
with respect to the sun, and with respect to its position around the sun?
Well, again, you always have to define these things in terms of what you're going to do, what's going to be your standard. The tropical year is the orbital period with respect to the equinoxes. The sidereal year is the orbital period with respect to the stars. By the way, the anomalistic year is the orbital period with respect to perihelion. There are at least 3 years. There are 2 different days. There's the rotation period with respect to the stars. That's a sidereal day. There's a rotation period with respect to the sun. That's a solar day. There are at least 3 or 4 different months. There is the synodic months, which is the orbital period of the moon with respect to the sun. This is the orbital with respect to the stars. The draconic month is the orbital period of the moon with respect to the nodes. And then there's an anomalistic month, which is the orbital period of the moon with respect to its perigee. Each of these have real meaning, and each one's useful in different ways. But you always have to state what you're going to be measuring the motion with respect to. There's got to be some standard there. Now, I think you're insisting there's only one, and it really isn't. I just give you examples of two different days, 3 different years, and 4 different months. Each one of them means something.
Okay. So this 365.2422 days, okay, is relative. Yeah, the tropical year.
Okay.
You're saying that's the time it takes for Earth to complete 1 full orbit around the sun relative to the local equinoxes measured from a point on the ground. And that's the basis for our calendar year.
It's actually measured to a point in the sky we call the vernal equinox.
Well, right, which occurs, we measure it from the ground, though.
Yeah, we measure it geocentrically, if you will, because we are on the Earth.
Right, okay. And you're saying that the sidereal year, which is the 365.25 something, is the time it takes for the Earth to complete one full orbit around the sun in the sun frame.
With respect to the stars.
The sun-centered inertial frame would be with respect to the whole universe.
Let me do it a different way here again. I think I mentioned this before in a conversation. Suppose you had the vernal equinox taking place, and the sun and the vernal equinox were lined up, and so was a star. If you waited 1 year, you would find that after 1 year, the sun would not line up with that star and the vernal equinox at the same time. I think there's a
11 minutes and 12 seconds or whatever.
Yeah, whatever. It's a slight difference, and you can't get them both to line up again because precession of the equinoxes is shifting the sky around as we sit here on the Earth.
That's the point.
That's why the mismatch.
Well, so what they've done, what you're saying is that they've done is when we slide the year slider, right? When we slide the year slider in our simulator, right? If we're sitting in the sun-centered inertial frame when we do it, then from the sun-centered inertial frame, if we very quickly increment that year slider, so we scroll it really fast, then it's actually going to shift the position of the Earth around the sun as well.
Well, that's because a year's gone by. It's again, if you go through one tropical year or one sidereal year, you're not going to be in the same location.
Okay, so now in addition to that year causing Earth to be in a different position slightly with respect to the sun-centered inertial frame when it orbits around, as we fast forward, 443 years, Earth in the sun-centered inertial frame, Earth will be 6 degrees behind where it was before, or ahead, or whatever. But
with respect to the stars.
yeah, sure. With respect to this, we're using the sun as the center point and the whole universe as like a grid that's fixed. So you could say with respect to the stars, it's equivalent. But in addition to that, is the Earth's axis also twisting, or is it just an apparent twist as viewed from the sun or viewed from the Earth because of the relative position change in the orbit?
Okay, this may be the heart of the problem. It is the axis of the Earth that's precessing. Right now, the north direction, the axis of the Earth is pointing very close to Polaris, to within about 3/4 of a degree. That's not always been the case. They didn't start calling it the pole star until about 500 years ago, because it was then got within about 3 or 4 degrees of the north celestial pole. It's going to get at its closest towards the end of this century, I believe, and then it's going to start getting farther away again. The north.
How do we verify that, Danny?
Hold on.
Let me finish.
The north celestial pole makes a large circle. It's got a 23.4 degree radius, and it makes a circle around what's called the north ecliptic pole. And the halfway between the north and south celestial poles, we have the celestial equator, and the equator intersects the ecliptic. The ecliptic is the plane of the Earth's orbit. Intersects it in two places. We call those the equinoxes. So
right.
since the celestial equator is connected to the rotation of Earth, then as the Earth's rotation axis precesses, the equator has to precess too. It just slides along. And it's that intersection of the celestial equator and the ecliptic which mark the equinoxes. And so those intersections slide along the ecliptic.
Okay, and in the sun-centered inertial frame, since we're using that as our visualization frame, then in order to keep those locked in at the actual equinox point, you're having to actually move Earth around the orbital circle it traces in the SCI frame. So my question, more specifically, is as you're doing that, if I keep this solar system inertial frame in a fixed grid and I simply move the Earth around in order to, year after year in order to keep the equinoxes aligned, then as that is happening, is there also on top of that in the SCI frame a twisting of Earth's axis, or is it just an apparent twist because of the relative change in orientation in the SCI frame? Because if it's an additional motion, right, then that would be an additional effect, and it wouldn't just be apparent.
What do you mean by SCI frame?
The sun-centered inertial frame. We are centered on the sun, facing grid north in the universe.
Grid north? What do you mean by that term?
So let me add real quick for clarity for both of you, right? So I wanted to ask Danny this too, because you're mentioning the tropical year versus sidereal year. Now the sidereal year does depend on the backdrop of the stars, right? But the tropical year does too, and I'll explain, right? Because from year to year, when you measure the equinox, right, it's the sun's position in reference to what? It's in reference to the celestial ecliptic. The ecliptic,
the sun appears to move west to east once a year along the ecliptic. But
exactly.
Again,
so in what the celestial ecliptic is what?
Well, the
stars.
A couple ways you can define the ecliptic. I would say it's the orbital plane of the Earth projected onto the sky, or you can simply say it's the apparent path of the sun through the stars throughout the year. Either one's a fine definition. The first one is more heliocentric. The second one is more geocentric. Either one works. But the ecliptic is a circle.
The point is that you're using the stars as a reference point for the tropical year. For this, from equinox to equinox, you're referencing the celestial ecliptic or celestial equator that's connected to the ecliptic.
Yeah, but again, let me go back again, and I don't know if it's really connecting here. If you watch the sun throughout the year, it will move west to east along the ecliptic, and if it lines up with a particular star, and then you wait until it lines up that star once again, that's one sidereal year. However, the intersection of the equator with the ecliptic will slide along the ecliptic. So if the sun is lined up with the celestial equator on the ecliptic, that would be one of the equinoxes. A year later, it won't be lined up again because that intersection of the two, the ecliptic and the celestial equator, have slid a little bit. So you can't possibly.
We're aware of that.
Pardon?
Sorry, I wasn't trying to clip you. I was just saying, there's no need to go over it again. We're tracking on all this. We're trying to specifically focus only on the point of disconnect instead of having to go through the basics leading to it again, because it's taking one more time each time we go through it. So we're tracking with all that up to this point. But what I'm saying, well, he's saying something slightly different. It's another point. But What I was saying is that, okay, let's use what you say is being defined as a sidereal year, right? In the heliocentric model, where we use a sun-centered inertial frame, where like you have the universe in the background. There's some stars to the north of Earth. Stars to the north in this grid. We'll define north as like up on our grid map. Stars to the north of the sun, to the south of the sun, the east and the west. Right? Those are arbitrary directions. I'm just using them so we have a human understandable reference. And all of that, all those stars and the sun are fixed, and the sun is in the middle of all of it, and the Earth is moving in a circuit around the sun. Okay, 1 year is the Earth returning back to its starting point in its orbit. That would be, as you said, a sidereal year. Okay, a tropical year, it would not return back to its same exact point in its orbit. It would be just a little bit before that, and over 26,000 years, it would slide year after year back incrementally until it made a one whole orbit of a difference. Now, I'm tracking with all that. I'm asking you, on top of that orbit, if we just stay in the SCI frame with the sidereal year, if we use the sidereal year so the Earth does in fact return to the same point every time, and there is no sliding around the circuit, it's just back to the same point in the circuit every time. In that frame, every year, does the Earth's axis also precess and twist?
Yes, that's what's causing the fact that the sidereal and tropical years are not the same. If it didn't precess, then it would be the same.
Okay. So here's go ahead. This is the part for his thing to come in.
So the point we're trying to make, and you kind of already conceded, dude, you think because Polaris shifts, right? Therefore, the Earth must be wobbling, correct?
Well, it's not just Polaris; it's the whole sky.
The whole sky.
Yep.
The whole sky precesses, right?
Yep.
With the precession of the
in my work, I have to regularly account for that. We have a coordinate system in the sky called right ascension and declination, and it's fixed with the celestial equator and the north and south celestial poles. And I can take a telescope and I can use setting circles on it. Today we generally use computers on it, and enter the coordinates, right ascension and declination, to point towards an object. But because the north celestial pole and celestial equator are continually shifting by a precession, that changes year in and year out. So if I have coordinates that are several years old, I will not be pointing at the right place. I have to go through little calculations to calculate the
Wait, hold on, real quick.
precession.
No problem. I get that. But the point we're trying to make here is because you believe that the Earth is wobbling on its axis. It's wobbling during the 26,000 year cycle, right? It completes a full wobble. And during that wobble, because of the Earth's tilt shifting, oscillating ever so slightly, right? You should have a shifting of the tropics and of the equator. Correct?
No, this. I'm going to say the celestial equator. I don't say the equator on the Earth. That's fixed with respect to the rotation axis. And by the way, this phenomenon
orientation of the orientation of the Earth's equator with the celestial equator is what he's saying would change.
Yes,
the relative orientation between them.
And because of that, the equinox and the season should shift.
And
it's actually part of your model. It's part of the Milankovitch cycles. They expect the tropics to shift ever so slightly from 23.4 degrees where they're at right now. So in a 26,000 year cycle, great year, right, is what they call it in astronomy or astrology. We should be seeing a shifting in the tropics. With the shifting in the equinox, you get a shifting in the tropics. They're
like 0.4 of a degree, isn't it? Isn't it like 0.4 degrees or something like that?
With
the shifting of the tilt, right? We would get a shifting of the tropics. They're connected. And that we don't see that in reality.
What do you mean by shifting of the tropics?
Well, because Earth's said to be tilted at 20. Yeah, Earth is said to be tilted at 23.4 degrees. So the place where the sun goes north and south on the map, it goes up to 23.4 degrees north on the Tropic of Capricorn and 23.4 degrees south on the Tropic of Cancer. That's said to be caused by Earth being tilted on its axis 23.4 degrees. But that 23.4 degree tilt is not constant. It varies across the 26,000 year cycle he's talking about. And so at one point in the cycle, it might be 23.1, and another point in the cycle, it might be 23.4. I can't remember the variance. I think it's like 0.3 or 0.4 degrees, but whatever it is.
Between 21 and 25 degrees or something like that.
Oh, wow, it's bigger than I thought.
It's about a 2 degree range, and it's over a very long cycle. That's something like
26,000
years.
Well, they debate on it, dude. They debate on it.
That is less well known than the precession of the equinoxes.
Okay, so the point he's making is, though,
the changing of the obliquity, we call the tilt of the Earth's axis, we call that the obliquity of the ecliptic. Because the obliquity of the ecliptic is changing slightly over long periods of time, it would cause the Earth to grow and shrink. It would be largest at the time of the maximum tilt and smallest at the time of minimum tilt. That does change slightly.
Okay, well, anyways, regardless of the size of the ball that you think we live on, what his point is that where he's going with this is that, even if we disagree if it's 21 to 25 or 22.2 to 24.8 or whatever the deviation is, there's a deviation. It's not always 23.4 degree tilt. And so over periods that are long enough, such as 2,000-3,000 years, there would be noticeable changes of, half a degree, 0.3 of a degree, 0.4 of a degree, etc. And you could calculate what it would be, but it's noticeable in the where the sun is at the tropics on the solstices, and where it is, at the equator on the equinoxes. And
People have this. There was the temple at Karnak in Egypt that Flinders Petrie tried to date by such an alignment. He was arguing a date that was much earlier than everybody thought, because based on the precessional cycle, thinking that the Great Hall there was lined up with the I think solstitial rising of the sun. However, that was pretty much debunked pretty quickly, but still that notion still goes around. The amount of change over the few centuries in the tilt is extremely small.
No, bro, we're not talking about a few centuries. There are temples built thousands of years ago that have alignments relating to the solstices. And so those solstice alignments could not be still lined up if the tilt of Earth is changing.
And indeed, people have attempted destruction of some of those structures by what you're suggesting there. They've attempted to date things that way. One I'm aware of, I've actually visited, is one in Ireland. The name of it is escaping me at this point. And they're arguing a certain date of construction based upon the change in the Earth's tilt.
You just said they failed to be able to date it?
Well, I'm talking about Petrie, but no, they've tried to do that, and they've argued about the date. There's a little bit of problem. There's a little bit of wiggle in there because of shifting of stones that took place in this one. Newgrange, it's called Newgrange. You can look it up. There's a Wikipedia page on it. I've been there, but they've tried to date its construction. They believe it lines up with the sunrise. The passage there lines up with sunrise on the winter solstice. In fact, they have a lottery every year where people can enter and get tickets to go there at sunrise to see the sunrise, if it's actually going to be clear in December. But even then, it's difficult because you have to make some assumptions about how it did line up inside in the chamber in the back end of that thing. This is not an exact science. It's pretty tricky. And to tell you the truth, I'm quite skeptical of that such precise dating.
Well, the problem is if you compare the heliocentric and geocentric models, right, then the especially even in an FE model, which is still a geocentric model of a different topology, either way you want to look at it. In a geocentric model, the precession of the equinoxes is caused by the celestial sphere itself rotating. But the sun is not affected by any of that. It has no bearing on the sun, and the orientation and alignment between the Earth and the sun never change. Now, the 23.5 degrees of the offset of the tropics to the equator in your model is due to the tilt of the Earth. In our model, it would be due to that is where the sun is lined up with the Earth. But you claim that there has to be this wobble built into it in order to account for the obliquity of the rotation of the celestial sphere around the north celestial pole, where we would just say it's just that the celestial sphere is wobbling. And so in order to make sense of which one of us is correct, we can look at ancient markers that are built into the ground to see, hey, are they still lined up with the solstices? Because if they are, it has to be the sky moving. It's not us. And if they're not, then we should be predictable.
Let me add to that real quick. It wouldn't necessarily be that the sky is wobbling, because it could still be in a circle. And Polaris, because it's not at the very center, would still have rise, ascension, and declination. Polaris, because it's not at the very center, would still have a circuit of its own, making it shift per century.
Let me back up here a second. You said a couple of times there your heliocentric viewpoints of this, and I would argue that the precession of the equinoxes is independent of either one of those. Let me describe the sky and the precession of the equinoxes from an entirely geocentric viewpoint. The heliocentric, the ecliptic is the apparent path, or the path of the sun through the stars throughout the year, speaking geocentrically. That defines the ecliptic. Whatever that is, that's what it is. You do have a celestial pole, a north and a south, but you only see one of them. It's a point in the sky around which the entire sky seems to spin every day. The halfway between the 90 degrees away from, say, the north celestial pole and 90 degrees from the south celestial pole, you have a circle around the Earth called the celestial equator, and those are fixed onto the celestial sphere sitting around the Earth. Now, if you make observations over a number of years, you'll know the celestial stay fixed. They actually swing in a big circle around a point that in the sky, which is 90 degrees from the ecliptic. That's called the ecliptic pole. And the celestial equator, since it's connected to the poles, must slide along through the stars as well. And the intersections of the celestial equator and the ecliptic must also slide. I just described it geocentrically to you. I didn't appeal to the Earth's orbit or the Earth's rotation, either one. I'm simply saying what we observe in the sky, and the two are exactly equivalent from one another. Keep in mind that the ancient Greek astronomers who discussed all of this were geocentrists. They believed that the Earth was a center of things, and it's not a problem either way because it's completely equivalent to one another. So what's happening with precession of the equinoxes from a geocentric standpoint is that the north celestial pole is pivoting around, circling around the north ecliptic pole, and so the intersection of the celestial equator with the ecliptic, which are called the equinoxes, right along. And by the way, that in itself will not change the direction of sunrise and sunset, albeit on the solstices, the equinoxes, or any other date in between, because those things are fixed in the sky. What will change those points, particularly near the solstices, would be if the tilt is changing. I should say the obliquity of the ecliptic. I won't say tilt, excuse me there. The obliquity of the ecliptic, which is the angle between the ecliptic and the celestial equator.
Right.
Yeah. So if that changes, there's a fixed relationship between Earth's poles and Earth's midsection band, which is the physical equator of the Earth. The Earth is the shape it is, and so the pole is always 90 degrees from the equator, is always 90 degrees from the pole. So if due to the obliquity changing, we get the tropics not being at 23.4 degrees north and south, then the equator wouldn't be at 0 degrees either. It would shift by however much they shift because they're all fixed at an equidistant distance from each other. And
yes,
so,
and that's independent of precession of the equinox. It's a totally different
correct.
effect.
Okay. So we were talking about words, and the whole conversation up until this point has built, and it's been good. But I think that because there was some imprecision about terminology, we had to clarify. That clarification has happened now. So now you're at where we are, where we're stating that if the tilt or obliquity, whatever terminology you want to use, changes, and the tropic bands go from being 23.4 to some other number, then the equator will also go from being 0 to some other number. Okay? And so that means that things that were lined up with the equinoxes based upon the angle in the sky, because it's all relative to the equator, 45 degrees north would be 45 degrees because, that's based on where it is because the equator is where the sun passes. Over time, as the tropics shift, then the equator would shift too, and it would no longer be 45 degrees. If it shifted a degree, it would be 44, and et cetera, and so on and so forth. And so these temples wouldn't be lined up. You can't have the tropics moving and the equator not.
No, the equator of the Earth will not change. That's what is going to change if the obliquity of the ecliptic changes, is that the Tropic of Cancer and the Tropic of Capricorn will change their position. It turns out right now, and has been for some time, the obliquity of the ecliptic is decreasing. So 100 years ago, the Tropic of Capricorn would be a little farther north than it is now, and the Tropic of Cancer will be a little farther south than it was 100 years ago, and the Tropic of Capricorn will be a little farther north. So the tropic slightly, but measuring that and determining that on the ground observationally is going to be extremely difficult to do. But you're right, there has to be a consequence of it. But the equator will be the same. And by the way, the on the equinoxes, the sun will rise due east and set due west wherever you are on the Earth. What will happen though is if the obliquity of the ecliptic changes, then if you look at the solstice rising or setting of the sun, that will change.
Yeah, because if you want to force if I go along with that, you want to force the sun at equinox to still be across the 0 degree equator line, then the way that you would compensate for that would be to say that the Earth, if it's spinning like a top, that the radius of the turning of its axis pole at the north and south point would become a little bit wider, and the top wobble would get a little bit bigger, which would cause it would, but the equator would still be the same because it would still have the same center line. It's wobbling around. So then you would see all the difference not at the equinox. You see all the difference at the solstices and at the tropics. But the point is still the same. There are temples built all around the world aligned with various different things. Some are aligned with equinoxes, some are aligned with solstices, etc. All of these things, if we check their alignments, we don't have any evidence that they've moved. You're saying it's not precise enough because you have to make presumptions that the buildings have shifted, and it's hard. It wouldn't be enough for it to be a huge difference, so we have to chalk it up to stuff like that, and you are skeptical of the precision. But I find that convenient.
People have attempted to do this, and there has been some dating of the construction of some sites based on the fact that if it's lined up with the solstice rising or setting of the sun, it's going to be shifted. Now, the one at Karnak I mentioned, it was determined later on that Petrie had missed the interpretation there was for.
You're roboting. Can you say that over again? Can you go back 5 seconds and start your sentence?
I'm sorry. I gave the example of Petrie with Karnak, and he had misidentified the alignment of a hall there, a long passageway in the temple. Actually, the thing was aligned to go with the direction of the Nile River at that point. And so Petrie was wrong about that. But people have attempted to date the construction of sites based upon that very thing you're talking about. And the best example, the only example I have any personal knowledge of, is Newgrange. You can look that up, and they've tried to date it. In fact, the dating of it is based upon this change you're talking about.
I see. If you could provide some references, that'd be interesting. We could pour over it in the meantime between now and whatever.
You can start the Wikipedia page on it, Newgrange. I believe it's discussed there. I also talked about Newgrange in a blog post on Genesis website after I visited. I don't know if I actually discussed that aspect, though. It's been several years. But Newgrange has been dated that way.
Based on what the shifting of the alignment of what once used to be aligned with the solstices and is now not?
Yeah.
No, he changed
Sorry, Danny. I just, looking shit up on Wiki, I would rather, if you're going to do that, at least find the sources that are in the Wiki link and post those. Let's not use Wiki itself as a source. Thank you.
That's fine, bro. I would go deeper than that, but I'm just saying, just to be clear. Yeah, but just to be clear, okay, but just to be clear, because it'll take time to do this, so it'll have to be the next time we talk. But what you're suggesting is that if we do this, we will find that the people at Newgrange are attempting to date the temple based on certain portions of the temple having some alignment with the solstices back then, and that alignment now having shifted in our modern day and comparing the deviation between the two.
That's correct.
Okay. All right. Yeah, this would be something I would love to look at.
Yep. Again, Newgrange is well documented. There are many sources out there. I don't have any top of my head, but just Googling Newgrange would probably get you where you want to go on that one. There are others, but that's the one.
Thanks, Danny.
So now, instead of looking up temples aligned with equinoxes like we've been doing for the past week, I guess we'll look up to temples aligned with solstices.
Yes, not the equinoxes, because that's not going to change. The solstices will.
I have a question, by the way, Danny.
Yep.
Are you familiar with comparing the ratios of distances in a triangles or magnitudes of velocities along the arms of triangles in order to determine angles?
You mean using trig functions?
Yeah, of course.
Yeah, of course.
What is your response to the angle not changing when one of the velocities along one of the arms was changed but not the other in Airy's failure?
Oh, I've written about that quite a bit. The problem is that he was testing for a particular ether theory at the time, and he disproved that particular ether theory. If you read the paper, and I have several times, Airy wasn't exactly distressed. He wasn't like, oh wow, we can't explain this. It was just he says in there was an ether theory put forth by a German fellow named Ziekenfuss or something like this. And yeah, and he simply disproved that of ether that he had. That's all. There's nothing. There's no smoking gun or a killing of a general paradigm. It's just the fact that they had various versions of the ether in the.
Well, Danny, that doesn't help if in your model there's no ether, right? Then the angle for aberrations has nothing to do with ether. It's just determined on the relative velocities of the vertical arm of the triangle of the light coming in and the horizontal arm of the triangle of the Earth moving. So saying there is ether or isn't ether doesn't change the observations he made. You would just look at it through the lens of there not being ether, and it still doesn't help you. You still have to explain why the angle didn't change. So let's presume there's no ether. That's fine. Why was there no angle change?
Why do you say there's no ether?
Well, I'm saying that we don't even need there to be an ether for this to still be a proof that the Earth's not moving.
Okay, but what was area?
Okay, so tangent theta equals V over C. This is the formula for stellar aberration. And if you change, there's only two dependent variables. There's V of Earth and C of the light coming through the telescope. If you change the V of Earth, if we were able to, kick the Earth like a kickball, the angle would change. If we were able to, change somehow the speed of light and increase the speed of light and make it double, the angle would change. So what he did is he slowed the light down, but the angle did not change. I'm asking you to explain how it could not have changed.
Well, let's back up a second. Let's take the water out of the telescope.
Okay.
And what do you see?
Well, compared to where they say the star really is and where we see the star, there's about 20.5 arc seconds of deviation.
And why is that?
It would be during the time, in your model, of course, during the time that the light is moving down through the telescope in its fixed path. The telescope and the whole Earth, in fact, that it's mounted to, is shifting horizontally out from under it so that by the time it reaches the other end of the telescope, it doesn't reach the center of the eyepiece that it was previously aligned with. It's slightly off, and that creates a small deviation angle.
So if the Earth isn't moving, then how do you explain that?
Okay, I'm glad you asked. So if the Earth's not moving, then it would mean that the light coming to the Earth from the star is being carried in at an angle already that we have no ability to change through velocity modification.
What causes that?
What causes that angle change from the time the light leaves the star to the time it gets down to us here on the Earth?
Yes.
It would be due to ether.
To
But
ether.
here's the point: even if I don't know what it is,
what's the ether? What's the ether doing to cause that?
there's an ether wind that's blowing around the Earth.
Around the Earth, which direction is it going?
West to east.
And which direction is it going 6 months later?
It's always moving the same direction.
Always move the same direction with respect to what?
The stationary Earth.
Okay, if you do
The center.
this, if you do this observation, 1 month, you'll tilt the telescope in one direction, but in 6 months you'll be pointing the telescope in the other direction. It shifts back and forth. It goes in a circle.
Yeah. So, okay. Yeah. Sorry, I know what you're talking about. Now I can understand what you're asking. Just to be clear, as measured on the day of the equinox at the equator, or sorry, not at the equator, whatever star is crossing your zenith, whatever star is crossing your local zenith on the day of the equinox, at that point, right, it will have this linear relationship. Now, throughout the year, this whole thing will change a little bit with its orientation, but it will still maintain a west to east direction.
So it's changing direction throughout the year.
Yeah. Cool. I mean, the stars are changing their orientations with respect to us throughout the year.
So why is the ether wind going in different directions throughout the year?
Well, it's still overall west to east. It would just be the inclination that's changing slightly. But as to why that's happening,
the inclination isn't changing. It's in the same direction. I mean, it's the same amount. It's just if you draw a line between the star and the sun, the direction you have to tilt the telescope is perpendicular to that line.
Yeah, but when we measure aberration, it's always measured equinox to equinox.
It doesn't have to be then. You can measure anytime you want. It doesn't have to be on the equinoxes.
Sure, it's just different magnitudes throughout the year. It's maximized on the equinoxes.
No. It's not. It's not maximized on the equinox. It's a constant throughout the year.
As measured from equinox to equinox, that's when you're able to get the 20.5 or whatever.
It's a constant throughout the year.
Well, you don't just measure. Okay, just to be clear, you can't just measure aberration at a point. You have to take it over time, because one measurement isn't going to be able to calculate aberration because all you see is an apparent star.
Right. When Bradley first did this experiment 300 years ago, he was looking for parallax. And when he started recording his observations, he was delighted after a month or two to see a shift taking place in, was it Gamma Draconis he was looking at?
Yes.
And he was very delighted. But then a few months later, he realized that the shift he was seeing was in the wrong direction. A parallax shift should have been in the direction toward the sun, but this was in a direction that was perpendicular to the sun. That's the relationship between the two of them, and they maintain that throughout the year. And the magnitude of the parallax of the aberration doesn't change; it's the direction that changes. It keeps a constant magnitude as it goes around,
yes.
So it's continually changing directions.
It's the yeah, okay. That's what I said when I was talking about the inclination. So, like, the angle of this rotation of the ether wind around the Earth will ever so slightly change throughout the year. That would be the equivalent.
So why is it doing that?
Well, physically, like dynamically, why is it doing that?
Yeah.
I couldn't tell you, man.
I don't. Why is it doing that? I mean,
the thing would be why. It would just be it's doing that.
It's as if the Earth is moving around the sun. Is the point? Well, otherwise, you're going to hypothesize that the ether is conspiring in such a way to mimic the motion of the Earth around the sun, as if the Earth is moving, though it isn't.
No, it's just as the sky rotates, the ether's rotating. I don't see. So the thing is I'm honest. I don't claim to know exactly how the mechanics of the heavens works. All we have is apparent kinematic observations, both of us. But you're asking me, like, what's the driving force causing the inclination of, like, the axis of the ether wind to change throughout the year? I don't know, because I don't know what causes the ether wind to blow in the first place. Is it Earth's magnetic field, or is the ether wind creating the magnetic field? Like, we don't know. Or are the stars themselves some kind of source that impose a force on the ether and blow it? Or is the ether causing the stars to rotate? I don't know. But what I can say is, no matter which model that you use, based on the laws of optics and based on trigonometry, if we slow the light down in the telescope, the angle of aberration should change. And it did not. And I'm asking you to explain why.
Well, again, before we get down the road and talk about Airy's observation, we need to talk about aberration in general. It had been routine by the time Airy was doing his work. It had happened for like 150 years at that point. And The simplest explanation, with the fewest amount of assumptions, is that it's itself an indication of the Earth moving around the sun. Now, you ask about Ares, and I do object to people calling it Ares failure. All it was it proved a failure of one particular theory of the ether, mechanical ether. When I say ether, I'm usually talking about the mechanical ether. It's important in talking about the ether that we define exactly what we mean by that. The ether, the mechanical ether, the classical ether, was the medium for which light was supposed to be traveling through empty space, otherwise empty space. And they had various experiments. Piezo did a famous experiment, and other people did as well. And they found out that no single theory could explain it. One of them was that this thing was fixed with respect to space, and the Earth was moving through space. But that didn't jive with certain experiments were done. So they an entrained carried along by the Earth, and that explained some results, but it didn't explain other results. And then there was a partially entrained ether, where the ether was only partially carried around with the Earth as it moved through space. One by one, different experiments were done that tested these various theories, and one by one, each version of the theory was eliminated. So people were frustrated. By the time you get to the Michelson-Morley experiment seemed to be the one that would settle it all, and it got a null result, which people were tearing their hair out at this point. No single ether theory could explain it all. And that's why it remained kind of a mystery for a couple of decades after that.
Well, to be clear, I don't want to. Michelson-Morley is very relevant, but I don't want to jump into a discussion about that until we make clear the relevance here in Airy. But you're talking about different ether theories. I grant you that there were many different ones, and regardless, and here's the problem that I see: regardless of which one was accepted or which one it was trying to be interpreted through, the fact is that today everything is interpreted through a model in which there's not even an ether at all. So one need not utilize any ether theory to analyze Airy's experiment today to see if it still holds up under the laws of the formula that were involved. If I take the ether away and I say, okay, there's still stellar aberration, I would have to say, okay, well, since there's no ether, ether's not causing stellar aberration. It has to just do with the ratio of the velocities of the light and the Earth. Well, if I hold that metric to be true, then if I change the velocity of light through the telescope, the angle would have to change because that's the cause of the angle in the first place. He changed the velocity of the light in the telescope, and the angle did not change. What is your answer for that?
Well, I would dispute the statement that there is no ether. There is no classical or mechanical ether, but the ether is the electromagnetic waves theory. And that is the foundation of special relativity. Maxwell's theory was published by Maxwell in 1865. It was then redone. It was reformulated by Heaviside later, a couple of decades later.
Oh, I'm very familiar with that. Very, very garbage work that he did, but take away the A field. But let's not get into it too deep. Continue, sorry.
We've distilled it now down to 4 equations. And those 4 equations are expressions of Ampere's...
Sorry, go ahead. I get excited talking about this stuff. Sorry, go ahead.
It distills down all these different things we observe, such as Ampere's law and such. It's an incredible theory. It's very complete. It explains everything we know about electricity and magnetism. If you ask some physicist what's the best physical theory we have, many will say some form of relativity. Others would say quantum mechanics. I disagree very strongly. I think Maxwell's equations are where it's at. It's the best theory we have. Physics of the transformation to modern physics quite well. And what Maxwell found when he solved the 4 equations, well, he had more than 4, but today we just do 4 of them. And he found that you get these oscillating waves that move mutually perpendicular with a that defines a plane, and then there's a wave that propagates perpendicular to that plane. And he was able to predict the speed of the wave, and it turned out to be exactly equal to the measured speed of light, which just flew him.
Hold on a second. Hold on a second. You're correct on most of that, but I just want to clarify. He didn't, as you said, there was more than 4. There was like depending on how you count them, but 16 to 20. Yeah, 16 to 20, depending on how you count them. But the Heaviside formulations, the simplification of the 2 E's and the 2 B's is not equivalent because they got rid of the A field, which Maxwell used to build all of it upon, which he derived that based on there being this sea of a universal fluid with rotating vortices in it, which created undulations throughout that sea, which were creating real physical mechanical forces, which manifested as electricity and magnetism. If you take away that fluid or that medium, you don't have any A field to be derived in the first place, which is one of the reasons later that they did away with the A field and they just used E and B, but then you run into all kinds of problems, such as you can't explain how E and B self-sustain each other, and you can't even explain things like capacitors or vacuum capacitors without the A field. But I don't want to get there yet. I would love to talk about it here in a moment if you want to. I just still want to focus on the topic, because if you're saying, well, there is an ether, but the ether is just the electromagnetic fields, it's not the ether we're talking about. It's not an ether that would cause an effect where you slow the light down and the angle stays the same. That's the fundamental problem. I don't want to go down a rabbit hole. The angle didn't change, and it should have when the light slowed down. Why didn't it?
I'm getting to that. Is the you get this very good description of the thing. And one of the weird things is the fact that tumbled out of this was a new medium for the speed of light. For 65 years, more than a half century, physicists had been pursuing a mechanical medium they called the ether, and in one fell swoop, Maxwell was able to show that there was not a mechanical medium; it's actually vibrations in electric and magnetic fields, which is more ethereal. It's not this mechanical sort of medium. I don't think Maxwell fully understood what was going on. If he would have lived long, he died fairly young. He might have figured it out because he was brilliant. But the point is, people realized soon, pretty quickly, really, that the speed of light in this is invariant.
You're hot, Mike and Alan.
The speed of light was invariant with respect to inertial reference frames.
It was no. In Maxwellian dynamics, the speed of light was invariant to absolute space because he was still using that reference frame back then. You see, Einsteinians don't have absolute motion. Maxwellians did, originally speaking.
Yeah, you're right. Heaviside reformulated it.
Right, but the problem is those four equations, those simplifications, don't work universally today, Danny. Those work for classical electromagnetism, but when we get into like really nitty gritty electrodynamics, like QED and stuff like that, and gauge theory, you still have to use the vector apotential equation formulations in order to get stuff to work.
That's because you're talking about a very different theory at this point. We're not talking about that. We're talking about the propagation of light.
Well, you can't. Okay. Before we get, like I said, I don't want to get into that until we answer and address the question. You said you were getting there. Please get there. Why did the angle not change in Airy's telescope when he slowed the light down? When he changed one of the only two independent variables in there, or dependent variables, sorry.
This is very complicated, and I'm not really prepared to discuss it today, I must say. But suffice it to say that the results, and you're not going to like this, I'm sure, but the result of Airy's experiment are consistent with special relativity.
They're consistent. How? Yeah, so we have already specifically used the formula necessary for aberration in a relativistic versus a classical setup, because they don't deviate by very much. They're very, very small deviations. To math all of this out, and the deviation difference, relativistically speaking, with SR, I think was like 2 or 3 10 millionths of a degree. And Airy expected to get 6.8 to 7 arc seconds, something like that. So
he was he was thinking about in a class, not in special relativity.
It's actually even worse than that, if you don't mind me cutting in real quick.
Sure.
So there was an experiment done by Faulkner and then later done by Michelson about 10 times where they used a rotating mirror and a light path that would hit a mirror and reflect back. And what they did is they introduced a tube of water in between one of the mirrors that was between the reflect back mirror and the rotating mirror. And the purpose of that was, to just see if the light would slow down and how that would affect the angle. And there was two different predictions, right? One was from the emission theory. One predicted that the light would increase as a function of the refractive index. So it would accelerate, it would go faster, so meaning the angle would decrease. And the other one was that, the wave theory was that the angle would increase because the water would slow, that the water would slow the light down, and they measured the angle increase. And then Michelson then repeated this a multitude of times. So they already knew that there was going to be if there's transverse motion, right, when the light comes in, there's going to be an angle change, like irrespective of any ether theories. And if you try to apply like Piezo, for example, to say like, oh, well, maybe it cancels it out, because that's kind of what the explanation was that they gave earlier, is that maybe the ether is bouncing around in the telescope and it's carrying it in the opposite direction of motion such that it cancels out the effect that the motion would actually cause. So in the 1970s, a guy named R.V. Jones did transverse ether measurements where basically he had a rotating disk. He had light coming in perpendicular to the rotation, and the velocity boost is always present and it's always positive irrespective of the direction of rotation, because he would let it go clockwise and counterclockwise, always changes it in the positive. So either way you cook it, like there has to be an effect because the light slows down. It's a physically real thing. If you have a cup of water on your desk and a laser meter, and you measure that cup in air from the top to the bottom, it's going to give you, whatever the cup is, like let's say 10 centimeters, right? You fill it with water, well, now it's going to be 12 centimeters or 14, whatever it is. And that's a real thing that can be tested. So there is a real timing difference. So if there's an actual real motion that's occurring, there has to be, there has to be an increase there. Otherwise it's not, otherwise one of those things ain't actually moving.
And,
so anyway,
real quick, just to finish up on the SR point that you make, thank you for adding that, Alan. That was very valuable. But the SR point that you made, Danny, just like Alan said, this is actually also on page 1 of the Michelson-Morley paper. I encourage you to read it. I'll go ahead and put it in the chat right now so that you can reference what I'm talking about. In order for that angle to not increase, right, they would have to have the light being carried in the opposite direction and or sped up in order to make up for the difference that they expected to be there. So in order for that difference that they expected to be there to not be there, right, and in order for it to happen that way, you would have to increase light beyond c, which also is not compatible with special relativity. So in order to even do that in the first place, you have to speed the light up to get it to make up the difference. And this was, of course, this was before they knew about special relativity, hadn't been invented yet, so they had no problem doing that at the time, right? But they knew it was absurd to think that would happen. They just, mathematically, they had no reason it couldn't happen. They just knew it was absurd. Einstein came along and said velocity is greater than c could not exist. So therefore, within that paradigm, you don't have like a relativistic way to make up for that expected angle change versus there not being one, because in your emission theory of light, you would have to have light sped up. And in the undulatory theory, if you say you have to have it carried in the opposite direction of motion, which is perhaps even more absurd. So you really have nowhere to go to say why the angle didn't change, unless you just say Earth's not moving and the angle must not be caused by its motion. Through process of elimination, that's the only logically valid case that's left to explain it. Are you there, Danny?
Yeah, I am. I'm just listening. I do want to say I do appreciate your attitude. So many times I listen to stuff going on here and people are arguing and it just really gets ugly and contentious. And this has not been contentious in the least. So I appreciate that.
Oh, same to you, man. I've been to school, like I know enough to know that you can't talk like that with people, and I don't have a reason to get upset with people. I'm trying to continue on doing what I'm doing in my life and, have a good life and do all that. But this is still very important to me. And, if you want to talk in an academic setting, you can't be like that. So that's how I just try to talk anytime there's an intellectual conversation going on.
I want to say thank you to Danny, too. And you, I don't know who you are. Sorry. But I do want to thank you guys for having a very cordial conversation here. It's been very good to listen to.
I often hang back here, and people may wonder why I don't jump in very often. I'm careful who I talk to. I want to be treated with respect, and I want somebody I can talk intelligently with. And when people are shouting back and forth, you can't do that. So I'm very choosy about who I choose to talk with and what subjects I choose to talk about. I'm most comfortable talking about astronomy topics because that's what I do.
Well, if you're done talking about Airy, I'll give you of course, I'm going to hand you the mic back. But if you don't have any, if this is the junction where we can't go any further because you just, you fundamentally either disagree or lack a way to want to continue in that trail of discussion, we can hang it up right there and just leave it with the conclusion of, your position is that there's an SR equivalence and mine is that it wouldn't work. And we can leave that up in the air if you want and let people think for themselves. I don't know if you want to comment on that or not, but I would like to talk about
that's fine. I think your suggestion is great. We can move on to some other topic here.
Well, the thing that you brought up about Heaviside and Maxwell, I think is very relevant. So I've actually been talking to some EE people earlier in the week at work about this. And I just I want to know what your impression would be. So as we just said earlier, Maxwell originally had depending on how you want to count them or count the ones that have names, there's 20 or so, 16 to 20 equations that he had. One of the things that Maxwell did is when he made all these, he felt like he had actually, Danny, a complete picture of electromagnetism. He felt like he had figured it out completely, except there was only one problem that he had that he couldn't quite explain, and he had to do something to fix it. Do you know what that was?
What was that?
It was the inability to explain the behavior of a capacitor, especially a vacuum capacitor. Because just using, all the known existing circuit laws, especially Ampere's circuit law and what we now know as Kirchhoff's laws, when you have a capacitor and you hook it up to, something that can charge it and you let it go and it starts charging, the current in the wire, let's say we just use a regular series circuit, it's just a rectangle, you got a rectangle with a capacitor on one end and a source on the other. The current in the wire has to be the same as the current in the gap between the plates, okay? But based on our conception of what current is just the motion of charge in time, then there's no way to explain, well, wait, how is there current between the plates? Because fundamentally, two wires separated by a gap is an open circuit. Those wires are a foot apart. It's an open circuit separated by a foot. If I put horizontal plates on the end of those wires, it's still an open circuit separated by a foot. But somehow magically, now that I put plates there horizontally, current begins to flow. And so this was a very curious thing for him. He's like, I don't know quite how to explain this within this framework that I'm using. So what he did is he invented what has now been known today as Maxwell's displacement current, in which he basically said, okay, we're going to take Ampere's law, which is based upon the motion of charge, and we're going to add an extra term to the end, which is the change in the electric field. And so now when we calculate total current, instead of it just being conventional current, it's going to be total current equals conventional current plus displacement current. They said displacement current is not truly a real current per se, because it has nothing to do with charge, because there's no way charge can be moving between a gap. It's not touching it. It's not possible. but it's effectively, it works the same as conventional current, and it has the same effects as a conventional current, and mathematically you treat it like it's conventional current, it's just not. And in order to explain the capacitor, what they did is they said that, well, what happens with a capacitor then, what must be happening is you have charge that's, collecting on the plates, but it stops there because it can't go across them, so it's just on the plates, but it travels no further. And this creates an electric field, which is time varying because it builds up from 0 and it continues to build up until it stops charging. And since the electric field, it starts out at one value and it's changing through time, a time varying electric field will create a current and also a magnetic field, which you can measure in the gap. So that's what they did. But I say to you that there are two problems with this, and also an experiment which shatters the whole thing apart. Would you be interested to hear it?
No, you're wrong already.
So the first problem is when you hook that source up, let's say it's a battery. You have an electric field on the plates now. Okay, let's say that it's even better. Let's use a constant voltage source, which is constant. If we use a constant voltage source, we hook it up to these plates, right? It's constant. It's not time changing yet. It's not time varying yet. The only way that we're going to get a time varying electric field between those plates is if we create an asymmetry between the charges on them. Well, in order to get there in the first place, before we can get to that asymmetry, first the electrons would have to move from one plate all the way through the circuit to the other, right? All the electrons in the circuit have to move at the same time. Well, that's an issue because you can't even get the charges to flow and move in the first place unless you have a closed circuit. So in order to get a buildup of charge on the plates, in order to create the time-varying electric field that you need for a displacement current to exist, you first have to get the current to flow, and you can't get the current to flow if the circuit's open. So it creates a causal paradoxical loop where nothing can get started. That's the first problem. The second problem is that there is this thing that's known, I wouldn't say it's well known because most people I would say probably don't know about it, but people who are well versed in electrostatics do. It's known as a dissectable capacitor. Have you ever heard of a dissectable capacitor, Danny?
No.
Okay. So it's basically like this, and I will go ahead and put, for everyone else's viewing pleasure as well, a link to it. It's pretty short but very informative that you can look at it. It's called a dissectable capacitor, and what it is you take, two plates and you put a dielectric in between them. Okay, this guy uses a mylar sheet. Okay, just some type of plastic sheet. But you take two plates, you put a dielectric between them. Now you have a capacitor. You charge it up. Okay, you take a grounded lead and you touch it, it discharges. Everything's normal. What this man does is he creates that capacitor, he charges it up, he takes insulated suction cups, grabs the top plate with the suction cup so he doesn't shock himself, and picks up the top plate, which is the charge plate because the bottom plate's grounded, and lifts it off of the capacitor, and he's like, okay, look, nobody touch it, I don't want you to get shocked. And then he's like, oof, and he pretends to fall for a second, and he grabs the plate with his bare hands. He's like, look at that, I didn't get shocked. And he's like, and just to show you, let me charge it up again. He takes the plate off, and he sets it off to the side, and then someone touches. They take the dielectric sheet off. Someone touches the grounded plate, and then touches the positive plate too at the same time. No shock. He's like, oh, that's weird. He's like, you know what? That dielectric I took off that you're holding for me, that you've been passing around while this is happening. Can you pass that back up here? And so they pass it back up, and he takes the dielectric sheet. He puts the dielectric sheet back in onto the plate, and then puts the top plate back on and puts it back together. Takes the grounded lead and touches it. It discharges. They're like, whoa! Like, where did that discharge come from? Well, it came because the energy was stored in the dielectric. And just to prove the concept further, he's like, let me get two sheets. So he gets two sheets, puts two sheets of mylar in between the plates, charges it up all again, takes it apart, takes the two sheets out, hands them to somebody. He's like, all right, now give me one sheet. Puts one sheet in there, puts it back together, touches it with a grounded lead, boom, shock, discharge. He's like, okay, takes that sheet out. He's like, gives me the other sheet, puts it in there, puts it back together, touches it with a grounded lead, boom, a discharge again. Both sheets created a discharge independently, individually. And he's like, all right, now to prove it even more, he does a third case, puts the two sheets back in there, charges it up, shows that it discharges, charges it up again, takes the top plate off. He says, now watch this. Takes the top sheet and flips it over because the sheet, obviously the side that's touching the positive plate will be positive. The side facing towards the grounded plate will be negative. When he flips the top sheet over, the positive sides of each sheet are now opposing one another. So the net electric field between the sheets is now zero. So from the contribution of the sheets alone, there is zero net electric field. But if there's charge on the plates, there still would be an overall net electric field. So when he flips it over, puts it back in there, puts it all together, watch this, takes the grounded lead and touches it, there is no discharge. Then he takes the plate back off, flips it back over to the original orientation of the top sheet, puts the plate back on. When he touches the grounded sheet, it discharges the crap out of it, okay? And he's like, see, what this demonstrates is that the charge was never stored on the plates. The charge is stored in the dielectric. But here's the last problem, Danny. In order to describe this in terms of the dielectric, what they usually do, if you want to say the energy storage is in the dielectric, they don't say the charge is in the dielectric. They don't say charge. They say the energy storage because it's stored in the electric field. What happens is The dielectric is said to be polarized. The electric field inside that capacitor is acting, it's interacting with the lattice structure of the material, and what it's causing is it's causing the electrons, they say, of the dielectric to get geometrically rearranged within the material so that there's an asymmetry with like more negative charges on one side and more positive charges on the other. So it's kind of like a rubber band that wants to get snapped back into place. It stores this potential energy in the electric field. So it's all in terms of electron orbitals. They say that the electric field creates a geometric reconfiguration of the electron orbitals, and that's how the energy is stored. He's like, but here's the problem. We've demonstrated that the charge is not on the plates. We know there's no charge on the plates. So the only thing you have left now is electric field to deal with. And you say it's based on the reconfiguration of the electron orbitals. I can show you, everybody in the world knows that we have vacuum capacitors. Vacuum capacitors also work. Tell me where the electron orbitals are in a vacuum capacitor. The dielectric is the vacuum. Where's the vacuum's electron orbitals? And that's the same question I proposed to you, Danny. We know that there's no electron orbitals for a vacuum, because the vacuum is not said to be any material at all. But unless there's some kind of material, you can't polarize it. The vacuum is actually being polarized, as can further be demonstrated, because if you use a vacuum capacitor and you continue to charge it past the free space permittivity value that it'll hold, then you'll even get a vacuum ionization and discharge. You'll get a spark in the vacuum itself, and in that spark, there's ionizing radiation coming off the arc. There are electrons and positrons and X-rays coming out of the vacuum because it got polarized so hard it couldn't take it anymore. None of that is possible unless the vacuum has something in it, which is some type of material which is polarized like any other dielectric. This shows that the only way to explain any of this is not to use these E field and B field equations where they feed off of each other. You have to go back to the A field, and the A field, Danny, is the ether. So you can't. Yes, sir. Yes, sir. Please view that video. See, because here's the thing. I don't know you. Real quick, Kepler, and then I'll hop off the mic. I don't know you personally, Danny, right? So I cannot in any way speak to your character. But what I'm not going to do is claim negative things about it by default, because I don't know you. Everyone should get the benefit of the doubt. So what I'll say is what I consider myself to be is an experimentalist. I don't like Einstein just because I disagree with him a lot, but he did have some really good things he said at certain times. One of the best things I ever heard Einstein say, it was a quote, he didn't come up with it, but it was experimentum summus judex, which is experiment reigns supreme, or experiment is the supreme judge. In other words, our entire understanding of physics and science and all these theoretical claims we make, theory is cool, but experiment reigns supreme. Experiment is the supreme judge by which we determine what's right. And so if you tell me that the charge is on the plates and you tell me that it's electron orbitals and all that, if my experiment says otherwise, I don't care what you say, because the reality is shown when we demonstrate the experiment. So I would encourage you to go look at this stuff and think on it. Maybe we can get back to it in the future.
All right, thanks.
Absolutely. It was good talking with you, Danny. I don't want to hold the mic anymore. I know we've been here for a while and it was impromptu, so let's open the space back up to everybody else. But it's been a pleasure with you, speaking with you, sir.
That was very insightful. Thank you, guys.
I would encourage everyone to be intellectually honest with this and see where it might take them, where the experiment takes them, not the preconceptions that we layer on top of them. Well, don't everybody jump in all at once. There was a lot of talk happening before I got here, so I don't want to stop any of that.
Was anyone discussing the coolness of the A field vector potential being used to derive the magnetic and electric fields? Because if they weren't talking about that, I mean.
Yeah, I mean, the magnetic field is just, and you know what's cool, dude, is like, I was thinking about this the other day when I was like, talking about it and reading it, and dude, when we talk about centripetal and centrifugal force, like that transverse at whatever the point of the edge of the rotation of the disk is, perpendicular to that, there's going to be a force outwards or inwards, right? But it's going to be perpendicular to any point along the rotation. It's going to be tangential everywhere. Well, if we think about how electric and magnetic fields are coupled, they're coupled perpendicular to each other all the time. And when we think about the magnetic field is defined, B equals nabla cross A, or in other words, the magnetic field is equal to the curl of the A field. This swirling rotation of the A field is what the B field is defined as. Well, if this E field is swirling at any point that you measure that rotation, you're going to have a perpendicular component that's going to be electric. It's going to be the electric field. And that's what we see in real life. Everywhere you look, magnetic fields and electric fields are perpendicular to each other.
How dare you?
It fits perfectly, dude. This fluid is swirling around, and at any point that you measure it perpendicular to that point to its rotation, at that point, you got an electric field component. Yeah. And the electric field is actually the scalar potential combined with the change in the A field. And that change in the A field would be like, if you were to try to think of it in a physical picture, the scalar potential would be like how much A you have, or in other words, the compressedness of the A. So if we say ether, I'm just going to use ether, right, to see like the analogy here. If the A field is the ether, then the scalar potential would be at any given point how much ether I have, because it can be compressed and expanded. It can be compressed and rarefied. So the scalar potential is how much I have. It's the compressedness, and the dA dt, the change in the A field, that would be the motion or the flow of it. So if I use fluid dynamics, it would be how much ether I have and how fast it's flowing or moving, and that is the electric field. And that would make perfect sense, because if I have a certain flow rate, but if I have more stuff flowing compared to less stuff flowing, I'm going to have more or less of a force or more or less momentum. So it makes a completely sensible physical picture when we talk about it in terms of fluid dynamics, because it allows us to make sense of where the magnitude of the electric field comes from.
So let me get this straight, my dude. You're saying that all electromagnetic principles were derived from a theory of ether being like the primary cause to establish that structural relationship with the magnetic and electric fields being perpendicular to one another. And when it came to doing experiments that tried to measure the velocity of Earth moving through said medium, that's where they decided to throw it out, because it became like, unnecessary, couldn't explain anything. As Danny was saying earlier, there was conflicting theories and results, and part of the confliction is that some of the measurements would give a first order change in the speed of light, and then other ones would give, well, they all gave a variance or whatever, but it wasn't to the magnitude of what they needed, so they could like throw it out as a null or treat it as like no change. So as that was going on, they would do another experiment, and then they would get more of a change than the other one. So the explanations that they were giving to explain one would conflict with another one. So like for Airy's example, right, we have aberration in air to the tune of 20 arc seconds or whatever, and then when they added the water, they were like, oh well, it didn't change. So what do we do? Well, the two lads, Fresnel and Stokes, said, well, maybe the ether is inside the tube and it's bouncing around, carrying in the opposite direction, yada yada, ad hoc, ridiculous. And then Michelson Morley came around, right, with their second order apparatus or configuration, where they were trying to defeat this ether trickery that seemed to be going on, that was making the Earth appear as if it were stationary when they tried to make measurements against it. And so when they got the velocity component of 7 kilometers a second, it was well outside of their margin of error, which was 2 kilometers a second, but it was obviously too small for 30 kilometers a second. So they weren't really sure what to do with that, because all theories put forward to explain everything was that there's basically no way that there's going to be a first order measurement of the change in the speed of light. And on the second order configuration, they expected to get that full velocity component. So the fact that they got one that was too big to ignore, yet too small to verify their cosmology, they quote unquote threw it out and had your boy truncate Maxwell's equations into the 4 that don't use the ether vector potential that explain things classically. But when you get into more advanced situations, you have to bring that vector potential back, and it's easily shown that it can derive all the solutions to all 20 or all 4 of Maxwell's equations, depending on which ones you like to use the mostesses.
Yeah, and also it's required in order to explain things like capacitors, and even capacitors are very simple. But when there's other effects like the Aharonov-Bohm effect. If anyone's never heard of the Aharonov-Bohm effect,
you should cover that real quick. That's insane, because like we have these particles, this electron, this ballistic projectile, and then it's like, well, why is it doing wave stuff?
Well, it's not just the wave stuff. Like, I mean, in the Aharonov-Bohm effect, it doesn't matter how you conceptualize it. You can use the electrons, and that's fine. But what it demonstrates is, actually, hey, Danny, are you still here?
Yes.
Okay, have you heard of the Aharonov-Bohm effect? If not, I'm gonna explain it for the room.
No, I haven't.
Okay, so it's AHA, RANOV, I think. Aharonov BOH. Yeah, there it is. Yeah, I'm gonna link the Wikipedia article to it and put it in the chat, and then y'all can look it up from there. But anyways, the Aharonov-Bohm effect. So let's say that you have a wire loop. You got a wire coming in, right? And then you can do it in a couple of different configurations. You can use it with 2 separate wires of equal length going to a point, or you can use it with 1 wire, which you split in 2 into a circuit and then recombine at the end and measure it. Like, you can do it different ways. But I'm going to use for our illustration the second case. So you've got 1 wire. Electrons are moving across it, from the left to the right, and then it splits into a circle. So the electrons take 2 paths: the upper half of the circle and the bottom half of the circle. Obviously, the upper half's moving clockwise, the bottom half's moving counterclockwise. When it gets to the other side of the circle, they recombine and turn back into 1 wire again, and they come out and they hit a phase detector. Okay, so what you do is you just, yep, there you go. The picture Gally just put it in there. So you put the phase detector on the other end, and you put current through the wire, and you measure it. And because we're not able to make the wires exactly 0.00000 the same length, you'll have a very small phase shift or phase difference. But what you do is you just zero it out and you treat your baseline reading as 0. So here's my 0 point. Here's a baseline reading. What you can do is you can make this loop very big, okay? And you can put in the center of the loop, you can put a solenoid, an electromagnet, okay? And the cool thing about an electromagnet solenoid is that the magnetic field is confined almost completely to the internal body of the solenoid. What it does is it's confined to the body, and then it wraps around the outer surface of the solenoid, and that's the magnetic field is confined in that way. So, if I've got a solenoid and it's like 1/2 inch in diameter, and I put it in the middle of this loop that's like a radius of like a foot or something, I can guarantee, both by math and by verification with tools and measurement devices, that there is no magnetic field extending past the solenoid out to the wires. It's not present. There's not one. And that's what they do in these experiments. They verify that. They can also verify that there's not any external electric fields either, because they can put this whole thing into a shielded setup, a Faraday cage, whatever you want to use, and verify that there's no external electric fields. So what happens is you put the solenoid there and you run the experiment, you get your baseline reading, right? Then you power the solenoid on and you do it again. Well, it shouldn't matter that there's a solenoid there. That shouldn't matter at all, because whether there's a solenoid or whether it's on or whether it's not, we know by both math and by hand verification experimentally with devices that solenoid is not producing an electric or a magnetic field that's touching the wire anywhere. So we would expect nothing to change. But what happens is there's a shift in the phase between those two, between the upper path and the lower path of the split current. What happens is one half of the loop gets sped up and the other half of the loop gets retarded or gets slowed down. So it changes from what the baseline reading was. The phase between the two loops or two halves will change. So there's a phase shift. Now, you cannot at all, there is no way to explain this in terms of the 4 simplified Heaviside equations, what they have now deemed to be quote-unquote classical electrodynamics, the redone version of classical electrodynamics, because if you use those, you will predict 0 contribution from the electric field and 0 contribution from the magnetic field, and you'll predict 0 contribution total, and there won't be any net force imposed upon the electrons, and there should be no change in the phase. But what we see is there is a change in the phase, and what is happening is that solenoid generates a magnetic field in the center of the loop, and based on Maxwell's original equations, B equals the curl of A. So when that B field is produced and it's going up out of the solenoid, it's going vertical, it's creating in the horizontal plane along which the wires move a rotation in the A field. And that rotation is extending outwards from the solenoid. And as it extends outward from the solenoid, it reaches the wires. There's a rotating A field where the wires are. And since, the wires have electrons moving through them, there's current moving through them, you determine all that in terms of the electric field inside the wire. But when we look at Maxwell's definition of the electric field, it's the amount of the A that's there and the change in A. So the previous electric field equation is now going to be different, because now we have this rotating A field that's touching the wire, and so it's going to subtract or add to the change in A at those, depending on which half of the loop you're in. So now the electric field internally inside the wire is actually being modified by that rotating A field, and that's what's producing the change in the arrival times of each half of the loop. That's what's causing the phase shift. So then this is a famous experiment. It's called a Aharonov-Bohm effect. But it shows that the A field itself is actually truly physical, because it's only the A field that can predict and model and correctly demonstrate the change in the phase in the system, because the A field is physically shifting and moving the electrons in the wire as they go.
Right. So a magnetic field is creating an influence, which is categorized and classified as an A field. The A field can be in a certain way, and it sets the tone for any electric activity that's going to pass through it. Basically, that's it.
Yeah. So when you power up the solenoid and you generate that magnetic field on the solenoid, B equals curl of A equals B. It's 2 sides of an equal sign. So anywhere that you have a magnetic field, you have a curling A field, and vice versa. So yes, I mean, ultimately, it wouldn't be. I explained it in the simplified way. The simplified way is to say that because there's a B field and B equals curl of A, then there's also a curling A field. The B field's not technically causing it. It's actually on the most fundamental level caused by the motion of charge. We're sending charge through the solenoid, because when you get into the more advanced theories and talk about it, A field isn't modified by B or E. A field's creating B or E. You can't have E or B changing A, because A is what's creating them. Well, so what changes A? Well, A is changed by the motion of charge, right? Charge is the only thing that can fundamentally and directly change A. So really the answer is that in the solenoid, the charge motion is modifying A, and now that A is in motion, we have B and E. That's technically the most fundamental way to look at it. But in the simplified form, what you said, yes.
But aren't these just basically conventions for saying the magnetic field influences, right, when charged, has a direct influence on how electricity passes through it, and they just call it the A field, like to pin it down. But I mean,
No.
if it's just if it's not really a thing, it's just part of the formula, then it is technically the magnetic field that's doing it.
But it's not the magnetic field that's doing it. You can take a Gauss meter and put the Gauss meter and measure at every point in between the solenoid and the wire and verify that there's zero magnetic field there. We know it's not the magnetic field doing it. That's the whole point of why this is famous and why it's known as like a thing. It's called the Aharonov-Bohm effect. It's because of that. The magnetic field also, what you said was also not correct about. No offense, I'm just talking about it. Is not correct in terms of.
I've literally never heard of this before. I'm literally trying to interpret what you're talking about.
Oh, I know. I'm just saying. I'm just letting you know. I'm not being mean. I'm just trying to correct everything. Real quick, 1 sec. The magnetic field is defined by the A field. So the A field is the fundamental part, and it is what gives rise to the B and E field. So the B field, the magnetic field, and the E field, the electric field, are created by A, not the other way around. Go ahead, man.
That sounds just incorrect.
Well, it's not. That's what Maxwell's equations say.
Just wanted to ask you real quick a couple of questions.
What's up?
In 20 seconds or less, can you explain what the A field is, just fundamentally?
It's ether. So if we just imagine this whole thing as a swimming pool of water, right? But the water's invisible. Okay, you've got this invisible water that creates magnetic and electric fields. So when
I got it.
Yeah,
I got it.
So
next question: has this experiment been done with a shield around the solenoid in the middle of those wires, both an enclosed shield and an exposed shield, kind of like a cylinder sitting over the solenoid?
As far as I best remember, I do think that they've done that, but I don't want to say that with complete certainty because I don't remember specifically enough. But it seems like when I was researching this originally back in the day that they've done it with both shielded and unshielded setups. I just don't want to tell you something wrong, but I'm pretty sure they have.
Found the same. They found the same results.
Yeah, I'm pretty sure that's been done.
Third question is not an insult at all, but I'm asking: do you work in the science fields or?
Let's see. How do I answer this? Yes, I do, but I don't want to give any more I'm very private online, man.
Did you go to college for sciences, or did you learn this on your own, or how did you?
Both.
Okay.
Did you say you did some extended studies at Aether Cosmology and in university as well? Interesting.
What's your major in? What's your degree?
Well, I don't want to give any more specific information than that.
Yeah, don't even give anything out because you dox yourself. These guys are, I wouldn't do it.
Yeah, what's the
okay, Jeremy? Jeremy, we're just trying to make sure that he has the authority. That's all.
It doesn't matter.
It
doesn't matter if he's an autodidact or he went to school for it. It's irrelevant. Go off what he's saying. Who cares where he heard it from?
Yeah, I encourage you to verify everything I'm telling you because I don't want you to take my word for anything.
Well, get back to the science fields. Yeah. Sorry, I'm just kidding.
It's impressive. It's impressive that you're so well versed in this. And I was just wondering if you were classically trained or if you taught yourself, or how did the knowledge come to be? Just curious. No need to answer.
I would say that I learned. I would say that I learned a lot more about this in my own independent studies than I did in school. Just because a lot of this stuff that I'm discussing, you don't really learn this unless you go into like doc or even postdoc level stuff. Because it has no bearing for the most everyday applications that you deal with, so there's no reason to learn it. And so I don't have like any postdoc or anything like that for sure. So I wouldn't have learned it.
You're on the side that there is an ether.
There's 100% ether, bro. Absolutely.
Yeah, and the thing is, his ether is only a fixed charges, so it's not a real thing. It's not the ether that you're talking about that moves suns and stars. So he's in a whole different category of the ether, and the A field that he's talking about, he's simply talking about the electromagnetic potential. That's all he's talking about. And that's something that is well recognized, right? The electromagnetic potential, and also the solenoid that he's talking about. By the way, I started electrical engineering, before I switched to software engineering, and that's why I went on to just get my minor in physics. And this Aharonov thing that he's talking about, it's kind of like when electrons are moving around in a circle, they kind of switch phases. That's all it is. It's a circular motion, right? It's not due to any ether garbage.
It's due to the A field specifically. I mean, even the Wikipedia article will tell you that, and it's disagreeing. Even it disagrees with you.
Yes. No, it doesn't. The electromagnetic field that you're talking about, the electromagnetic
field. As my dude was talking, you talked over and said that the video agrees with you and also disagrees with you. Like now I'm super confused and I don't even know what your point is. So if you could dial it back a little bit while the conversation is ensuing. I know it's tempting to get things out, but we would appreciate a nice clean convo here.
Yeah, Kepler, I temporarily muted you, Kepler. We're going to have a clean
Of course you
conversation.
mute me
Keep
because
yourself
I'm
out of here.
great. You
I'm not
always
going to let you
mute
ruin
the
this
greatest
conversation.
people. You always mute the
You're
greatest.
you're going to be muted. Sorry, bro. You're going to be muted for a bit.
Can I possibly ask my final question? If there is an ether in like 1 minute or less, can you explain how that would change anything?
Oh, yeah, that's a great question. That's one of the best questions all day. Yeah, so, well, I'm going to propose that there is an ether, and I'm going to say some of the consequences of there being one is that, number one, it serves as a universal medium, which gives rise to the fundamental forces of electricity and magnetism that we know. So it's the basis by which those can even exist in the first place. It's how we can predict them. Also, it serves as a universal frame of whatever it is, whatever kind of stuff it is. I don't want to venture to guess too much, but it serves as a frame against we can measure all motion. So, one of the predictions of that would be that, like, if there's an ether, then you would be able to use light and or electromagnetic phenomena as a backbone by which to measure motion without making any explicit references to any external frames. And that has also been done. If there is an ether, it would also serve as a basis to provide energy within places where there should otherwise be no energy, such as vacuums. That's also been demonstrated because all energy is motion of something. Every form of energy is the motion of something, whether it's thermal energy, kinetic energy, electric energy, potential energy. Like, there's motion involved in every definition of every kind of energy. So when we go to a vacuum where it's just nothingness, where it's an emptiness of anything, there should be no energy, but there is. It's called 0-point energy. So that comes from the ether. If there is an ether, you would predict that it would have material properties which allow for there to be fundamental constants arising from it, such as the propagation of waves through it, like any other elastic medium would have a certain wave speed. Ether would also have a wave speed. That's what gives rise to C. And actually, if you look historically, when they were trying to figure out what the speed of light was, there were a bunch of different methods that they used, and then they compared to each other to see if they were right. One of those methods just so happened to be they looked at the fluid dynamics equations for the propagation of waves through fluids as well as the propagation of waves through elastic solids, and they ratioed the electric permittivity of the vacuum and the magnetic permeability of the vacuum against those variables and plugged it all back in, and it ended up with 1 over the square root of epsilon mu, which is equal to C. So it perfectly predicted the speed of light. You would also predict that if there's ether, whenever stuff is in motion, it would have the ability to drag light with it or against it, which was proved by Piezo to be accurate. All kinds of stuff. I don't know how much farther you want me to keep going. You would predict that the refractive index of a material, if there's ether, the refractive index N would be proportional to the compressedness of the ether. So whatever N is, the higher N gets, the more compressed the ether is in there, because ultimately the wave speed's always the same. So in order for light to slow down, what actually has to happen is there has to be more ether in it for it to travel further through the ether path, and that's also been demonstrated. Lots of stuff.
Cool. So how did you measure the speed of light exactly?
Maybe one more. I'll add one more on it. Maybe a greater implication than any of this would be that if there is an ether, and because it carries some level of physical interaction with matter and the world, there would be a way to tap into it in order to harness it for mechanical purposes such as energy, or whether it's through electromagnetic means or otherwise.
Okay, that's exactly what I asked for right there. That last sentence or two. If you remember, I asked if you could do it in less than a minute, and you went on so long that I kind of lost focus. But that last bit is what I really needed. So if we're able to tap into it for energy use, why hasn't anyone done it, including yourself? Like I said, you seem to be very well versed in this.
That's a good question as well, and it's a little bit more of a difficult one, but I can only venture to guess based on what I've seen. But from what I've seen, the ether does not have a very strong coupling to matter so that you could use it to create like some kind of mechanical motion in a regular sense at normal velocities. It appears that the higher the rate of rotation is, or the higher the velocity of something is, the greater the magnitude of the interaction, of course, just using classical mechanics, of course. And so in order for us to measure a perceivable change, in order to be able to harness it, in order to couple it to matter or anything like that, you would need to get very, 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 high velocities. And so I think that might be one of the primary challenges as to why it's not been tapped into in like a meaningful way so far. But I'll say that this can be demonstrated to work at least in a few ways, because in a kinetic and an electromagnetic sense, I know of two things. So in a kinetic sense, I know of the guy, what was his name? I think it was De Palma in the 80s. He was doing tests with taking small spheres like ball bearings and stuff like that, and he would spin them and get them spinning to extremely high velocities, like we're talking like 18 to 27,000 RPMs, and then he would like throw them in the air and let them come back down. And he found that when he did that, the rate of rising and the rate of falling became different. It no longer obeyed like the regular acceleration of g as it fell, or rose or whatever. Because the prediction there is that once it gets spinning fast enough, it has a meaningful enough interaction with ether to be measurable against the classical forces. And then the second thing that I know is that it's called the Biefeld-Brown effect. So this involves voltage, which this would be instead of a kinetic force, would be just an electric force. But if you create a capacitor that's asymmetric, meaning instead of like a parallel plate capacitor, you might have on one end you have like a needle point, on the other end you have a sphere. Something that's asymmetric, not the same on the two sides. If you create an asymmetric capacitor and you conduct extremely high voltage across it, we're talking in like the hundreds of kilovolts or even megavolts ranges, the entire capacitor, the whole thing as a whole, the whole system will experience a net force against the direction of the asymmetry. And so that is one of the craziest things. I find that even more profound than the classical thing, because like that is not at all explainable within the framework of conventional physics, even including quantum electrodynamics physics. None of it. There's no framework which explains or predicts that at all. And this is talked about in the literature. The literature is pretty limited. You've got like Navy or Army research lab literature, and you have a little bit of private literature, and you have like some like big labs like Honda R&D labs in Japan or whatever that have worked with it. So very, very high level organizations that are working with it, and they've demonstrated that the effect works in vacuum, works under insulating oil, works in it's not from any classical effect, it's not from air or anything like that. It works in vacuum, but there's a net force imposed on the capacitor. And the best theory I've seen as to why, of course, they try to wrap it up in mainstream. They say they believe it's an interaction between the extremely high electric field and the 0-point field of the vacuum, which in my world, the 0-point field of the vacuum is just the ether. So the voltage gets high enough to meaningfully interact with the ether, and it's literally like it's operating like a regular fluid, and you're just pushing off of it, right? So
I'm so sorry to do this to you, but like in like 3 sentences, can you talk to me as a layman? Because clearly you're very well versed in this, and I am not. But can you speak to me as a layman in 2 or 3 sentences on why this hasn't been tapped in by anybody?
Okay,
I can do it for you.
It has. As of the most recent thing that I saw was as of last year, one of the space propulsion companies known as Exodus Labs built a demonstration working model in their lab and posted it up on Twitter. I was looking at that. I haven't seen it. I haven't really checked much into it since then, but they had a vacuum chamber with some asymmetric capacitors moving around in there. So it just hasn't been upscaled yet. It hasn't been well known enough, and now that it's just starting to, right?
Wait, what's the significance of that? They did what now?
They created Biefeld-Brown effect thrusters that they were using to move around in a vacuum chamber.
And how does that use the ether?
Well, based on what I just said, the Biefeld-Brown effect is not explainable with conventional physics, and the best known working theory as to how it works is an interaction between the electric field and the 0-point energy field of the vacuum, which is not a real field in any conception of physics. It would just be, in my world, that's what the 0-point energy comes from the ether, so it would be the electric field coupling to the ether that's creating the force.
Or magnetic field.
That's what the company said they're using is the ether, or what are they saying they use?
It's the Biefeld-Brown effect. Can you steelman
ether? Now I'm done.
Can you steelman the Aharnov-Bohm effect for me and explain why it's significant?
No.
Okay, that's what I thought.
Yeah.
Okay.
I'm just going by everything that you said.
I explained it 3 times for you with extreme clarity on the last one. You just kind of repeated yourself. So I think we're done here.
I think we are. I made my point. You made yours. I think everybody can make.
I don't think you had a point, but sure.
Yeah, I did absolutely, and you confirmed it. Thank you for that. Thank you for being honest.
Well, can I ask something just to kind of get it back to like I said, layman's terms? Is there a reason that electromagnetics cannot go through a vacuum?
Well, why they shouldn't be able to, or why they can't? Because they can. We can send wireless radiation through a vacuum.
Okay, so if they can, then what's it saying that these, like you said, the space agency created whatever kind of engine, and they say they're using electromagnetics, right?
Well, they're using an asymmetric capacitor. So once again, there's no claim as to how it's working on an ontological level other than it's the Aharnov-Bohm effect. Once again, you don't need to be clear, none of us need to know how stuff works to use it, right? Like if I light a fire and I want to use fire to cook my food, I don't have to know how fire is actually like the ionization at a chemical and electrical level of material and the lattice structure separating and releasing bond energy. Like I don't need to know any of that to cook my food. I just need to know if I put food on a fire, it's going to get hot. It's the same way the Aharnov-Bohm effect is being utilized.
So then, are they using electromagnetics or not to make these?
Yes. So they use electricity. They use a capacitor, which is electric.
Okay, but I asked why. I asked how or why is the ether not being used currently if it exists, and then you gave me that example of this space company. Now we're saying they are using electromagnetics.
Okay, I guess I need to be more specific here. I understand your confusion. So I'm telling you that the way that the Aharonov-Bohm effect works is ether is a necessary component. Okay. Now you're like, okay, but they don't say they're using ether. They say they're using a capacitor, which is electricity. Yes, but specifically, right? Specifically, if you just take a system, which is the capacitor, let's say an object, just think of it as a box. I've got a box, okay? I've got a sealed box, okay? Inside that sealed box, I have, electricity. Now, if the electricity doesn't come out of the box, if it never exits the box, it's just moving around inside the box, it will never be able to create a net force on the entire system. It's an enclosed system. It's an enclosed system. So without something entering or exiting it, without like a change of the system itself, intrinsically like going to externally, you cannot create a net force on the whole system. It's an enclosed system. It's an enclosed system. So without something entering or exiting it, without like a change of the system itself, intrinsically like going to externally, you cannot create a net force on the whole system. It would be like you're out in outer space, right? You're out in outer space. Unless you can like eject some gas, eject some rocket fuel, throw a ball and reduce your effective mass because you just transferred mass or something like that, and unless you can make an external change on your internal system, you cannot move yourself, okay? So that's the significance of this is inside this closed box, all they're doing is moving electricity around inside of it, and somehow it's moving the whole box. And what I'm telling you is the reason the ether is necessary is what is the box pushing off of? Right? It has to be pushing off something. Well, there's ether inside the box because there's ether everywhere. When the voltage gets high enough, it's able to push off the ether, and that's how it's moving. That's the Biefeld-Brown effect.
Well,
so that's how they're using ether.
Predicted using ether. All right, ether says it should change speeds in different directions. What next?
There's an example of why it's real. There's an example of a difference. You said what would change? That's a change. I mean, there's a whole list of different things. Every single one of them fulfills your question.
Okay, so that's what I'm asking you.
You can throw relativity out the window. There you go. There's a change.
But what would it change? That's what I'm saying. Like, what would be different? We'd just be calling something a different name. So the only thing that would change in that whole light example is, ether causes that. It still happens, but we're just saying ether's the cause of it. So nothing really changed in the experiment, in the observation. We just named it something different.
That's
Can you guys
right.
hear me?
Exactly.
Can you guys hear me?
Yep.
Okay, a big thing that would come out of this, right, would be so if you take the scenario of ether, right, and you start acknowledging it, all motion is going to be relative to that medium. Now, that's something that's measured through interferometry. So a big part of what would change, right, the idea that all the equations that are applied to the cosmos, so Newtonian dynamics, Kepler's laws, etc., that give us the nice concentric elliptical circuits that go outwards and define the distances to all the planets, etc., would be completely invalid. Everyone would know that that's a conceptual model now and it's not real because if those were real, the Earth would have a velocity component to it, and every time they try to measure it, it comes out to be 6 to 8 kilometers a second instead of 30 kilometers. So that's a huge fundamental difference. And then when you look into what interferometry is and what it measures, like a good evidence for it, right? Because we were talking about kind of some abstractness, I guess, a little bit, and maybe if you're not familiar with the significance of using a more fundamental field to predict changes in the other ones, and then that effect not being reciprocal, showing that the fundamental field that you were using supersedes the other ones in a hierarchy. Another way to look at it would be, what does an interferometer do and how does it make its measurements, right? So we take a nice coherent light beam, so a single source, right? Nice laser. It hits a beam splitter. It goes in 2 different directions, counterclockwise and clockwise to itself before it recombines. If there's no ether, then when that circuit is complete, clockwise and counterclockwise from that split beam, those beams should recombine and there should be no phase difference between them. There should be none. What they found is when the apparatus is orientated such that the arms facing north and south versus the perpendicular east-west arms, they show that there is always a phase difference when the light completes the circuit going east to west, but never north-south. That's extremely significant because what that means is the light is being retarded as it's completing the circuit, or it's being velocity boosted, right? It's catching a boost, and the distance that it's traversing from where it started is being preserved to create that difference when it recombines. So when it recombines, instead of being in phase, it's going to create little tiny gaps, little gaps caused by the destructive interference from it being out of phase. What you can do with those gaps, and this is the most significant part possible, right, is you can measure the distance between those gaps, those little black gaps, and the square of that distance is always proportional to the velocity that's in question, right? So when you look at modern inertial navigation systems, the experiment done by Ru Yong Wang, etc., what you find is that relationship holds true. And the only reason that would hold true is if we're in a medium and all motion is relative to said medium.
Okay, so like I said, I'm willing to grant you that is ether. That is ether. All right, it exists. But before this moment, the phenomenons were happening. The observations were happening. The measurements, the predictions were happening. And as far as I know, they're pretty dang accurate. So what does, after this moment, what does it mean that ether exists? What changes?
The point is
always
that
existed. Otherwise, the measurements wouldn't exist.
Yeah, the point is that, dude, your acceptance or explanation of something as being because of it or not is not going to change what reality is. Reality is reality because it is. Like, it's kind of like, I gotta tone myself down. I get a little bit too much with some of this stuff, but your question, man, is like, it's asking, well, if I understand how something works, how does that change the way it works or not? Well, it doesn't, bro. Like, your understanding of something will never change what's happening. But that's not a proper question to ask, right? The point is, if that wasn't the case, none of it would happen. We would see a different reality if it wasn't the case. That's the point. It has to be true, because otherwise reality would be different in all these ways we're talking about.
Your question is basically, who cares? That's your question, RL Photography. That's what you're saying.
I guess so, because if it exists or if it doesn't exist, nothing that we do changes.
Yes, it does.
Our equations might change, our predictions might change, but in whole, nothing changes. We just have a word now that we can use as ether.
Hey, bro, if the sun didn't exist tomorrow, if I snap my fingers and the sun didn't exist, what would it change?
No, that's different. That's an actual thing.
It's not different, bro. The point is everything that you list for me, you would start listing all the things that would change if there was no sun. And I would be like, well, how would you know that there's no sun? You'd be like, well, because all the things I just listed. I'd be like, exactly. It's the same way with ether. If there wasn't an ether, we'd be living in a different reality. That's not the reality we live in. Just like you live in a reality where there's a sun. You could tell me if there wasn't a sun, here's all the differences we would see. But the fact is, we do have a sun, so what does it matter?
I understand that, but what you're not understanding is I'm a guy and you call it the sun, but my name, I want to call it paper towel. And then all of a sudden science changes and said the sun is now called paper towel. Nothing else changes though. It's just a name. So you're saying that ether exists. You're saying that ether exists where we call it empty space. And if we all change tomorrow and said, you know what, ether exists, we were wrong. Nothing would change besides we have a name for it now.
That's not the same thing, because we know that there is an ether just like we know that there's a sun because of the differences. If they changed the name of the sun, nothing would change. But if the sun got deleted, everything would change.
Ether's not getting deleted. Nothing's getting deleted or nothing's getting added if we agree that ether exists. You're saying it already exists. You're saying it already exists. Whether I agree or
wait a minute, you're assuming that they're telling us everything that they're able to do with that ether if there is something, right?
No, bro, we don't even need to go there. New perspective, bro. Like RL. Okay. I know that I can get, like, if we just do this really slow, methodically, you have to be able to get this. You agree, just based on what you just said, if there was no sun, it would be different. And you said, but we're not deleting the ether, right? That's where we're at.
Right.
Okay.
Right.
So stay with me. If there was no sun, would you be able to tell me what the differences would be? At least some of them.
Why are you saying that we're going to subtract the sun away?
Just stay with me. Just stay with me.
Of course, there will be many differences if the sun was not there.
Okay. And would you be able to tell me what some of them are?
Yes, we'd all die.
Okay. Good. So now you ask me what would change with the ether. I tell you, if we were to, just like if we deleted the sun, if we were to delete the ether, I can tell you what those differences would be.
But I don't want to delete the ether. All I'm saying is we said, okay, it exists. No one's deleting anything.
Wait, RL, follow the analogy to completion though, right? Because in the same respect that you could list differences for the sun to describe how it would be different, we could do the same, right? So just follow it.
Okay, go ahead. I'm sorry. Go ahead. Repeat that.
You're good. Go ahead, Piezo. Take it away.
So if you were to delete the sun, you'd be like, oh yeah, this would change, that would change, that would change. We'd see all these things are different. Okay. We say the same thing with ether. We say, okay, if you were to delete the ether, this would change, that would change, that would change. All these things would be different. And you're like, okay, cool. And then we ask, well, based on what we see in reality, we can know whether or not there is a sun, right? And you'd be like, of course, we can feel the heat, we can measure energy, we can look at it with our eyeballs, right? We can see it. There's a sun. I'm like, okay, I agree. In the same way, we point to what reality do we see in terms of the ether arguments? Oh, we see a reality where the ether arguments are all true. Okay, there's an ether. So, like, it's completely equivalent to the sun argument. So when you then turn around and ask me, well, what does it really change then? It's not really changing anything. We still live in the same world we lived in 5 minutes ago before we figured out it was ether. Well, sure, dude. I mean, that would be like a person who, was born in the winter and lives at the North Pole, never sees the sun. And it's like he doesn't know that there's a sun. And then one day it gets to summer and the sun rises. He's like, oh my gosh, there's a big fireball. Like, just because you just learned something doesn't mean that reality changed. The sun was always there. Just because you didn't know it doesn't mean your world changes. It's kind of a silly question at the end of the day is my point.
So I think we just agreed. So just in your analogy with the sun, we're going to switch it to the ether. The ether didn't change. It was always there and nothing else changes, right?
The acknowledgement of human beings acknowledging whether something exists does not change nature. No.
Okay,
that would be absurd.
So that's the answer to my question I asked 30 minutes ago. If we acknowledge ether is in existence, what would change? Your answer should have been nothing.
Well, dude, most people, when they say that, like, hey, if we acknowledge it, what changes? What they mean is like, what would change if it truly did or didn't exist, not if we acknowledge it exists or not. Like, most people aren't asking the question, hey, if ether does exist and it really is a thing, but we just don't admit it in our conversations, what's changing? Most people wouldn't ask that because that's a kind of a silly question. The question is usually, what if it didn't actually exist?
No. That wasn't my question. So I figured out the problem. You assumed that I had some kind of ill intention behind my question when I was actually being very literal and asking.
It wasn't an ill intent.
Well, you're mistaken by my question and I was being very literal that if we agree that it either exists, what would change? And your answer should have been nothing.
Our understanding would change.
Yeah. I gave you a pretty good philosophical breakdown of what would have to change, right, in regards to astronomy and the cosmological views of Kepler and Newton. Like that's a huge change.
Explanations and measurements and predictions would change, but they've been going so great so far. They just get more accurate.
The world you fundamentally live in would completely change because if there's an ether, if you acknowledge there's an ether, now there's no such thing as a heliocentric model. It dies. Now we're the center of the universe. Now we're special and unique, and like this world was made, and we were put here for a reason and a purpose. Because there's only one center in the universe, and that's where we are, and we're here.
Can I give you some pushback on that? I would still wake up tomorrow, go to work, do my same thing. They would still be sending satellites up into space. They would still be sending things to Mars. They still send things to the sun. So nothing changes other than some calculations, predictions. Correct?
No. Do you understand that the distances and everything that they're basing off to derive, the calculations to tell you that they're sending stuff to Mars would be false? Like that's the implication.
That's what I'm saying.
All of that goes away.
The calculations would change and the predictions would change, right? The calculations, measurements, predictions, that would change, right? It would get more accurate because we know that it's actually ether.
Well, it's too late to change it now. They're already locked in. So that's why they can't ever publicly acknowledge it.
What do you mean it's already locked in?
That's what special relativity.
They've already claimed that they sent robots to Mars. They've already claimed that they sent robots to Mars. They already claimed, and the way that they did it is because they know, we're moving around the sun this fast and there's this many forces and Mars is this far away and we have to calculate for this gravity, and all that has already been locked in when they said that they sent a robot to Mars. So if all that's fake, then that they didn't send a robot to Mars, that's a lie. Now you know you live in a world where you're being lied to about where you live.
Oh, wait. They can't. You don't think they could just say, "Oh, look at this new discovery, the space whatever made with their capacitor thrust engines. Ether exists, and hey, next year we're going to send this thing to Mars using the ether equations, and it's going to get there 3 seconds before we predict it because our equations are more accurate."
Because if there's ether, all the experiments we already talked about show that Earth's not moving, and none of that stuff is real.
Oh, okay. So ether existing, acknowledgement of ether existing means that space and things in space aren't real. That's what that means.
It will lead to that.
That the physicality and
distances their way around that easily. I don't think that's going to be a problem for the people that make up those stories, right?
So I guess my overall question is, what about space do you think is not real?
Oh Jesus!
Well, Alan, can you say what you were about to say, please?
I can't even remember what it was. Oh yeah, I remember now. It had to do with velocity, but I kind of lost it. So.
He was asking. It was what about the robots on Mars? And you said they're already locked in. And he was like, how would there be ether? Why couldn't they just say we're using ether to get there now?
Oh, right. So the significance of this whole thing, right? The whole battle of Einstein versus ether in the early 1900s. What the significance of that was because all motion would be relative to it, and they had this device called an interferometer that would split a light beam in such a way that it would complete a circuit, and you could rotate that interferometer, and based off of how it was orientated, north, south, east, west, there would be a difference in the way that the light completes the circuit going clockwise and counterclockwise. So if those distances, I'm sorry, if that measurement, what's that?
Sorry, yeah, go ahead. If the measurement changes.
If that measurement changed in a way that it gave a velocity that would agree with 30 kilometers a second, then they could use that. But they had to throw all of that out because the velocity that they measured over and over again was way slower than what they predicted for everything that you're saying, like to send something to Mars, all of that stuff. In order for all that to be true, there's a lot of things that have to also be true, right? So Newtonian dynamics as applied to the sky, meaning GMM over R squared. So just the gravitational potential.
Real quick, Alan.
Yeah.
But hold where you are. You just explained GMM over R squared. Stay right there. I just want to clear this up in a layman's terms. Dude, they claim that Earth is moving 66,000 miles an hour around the sun, RL. They took a device to measure how fast it was actually moving, or what they thought would have been the Earth moving. They measured like 15,000 miles an hour, or 12,000 or something like that. And so 15,000 is nowhere near 66,000. And so when they measured it, they're like, oh, well, this doesn't work in our model at all. We've already built an entire universe with all these numbers, all these sizes, all these distances, all these speeds. We've already built the whole thing. So when we measure our measurement and it's supposed to be 66,000 and it's only like 12 or 15, we're cooked. So what they did is they're like, that 15,000 miles an hour we measured? Yeah, we're going to lie and tell the public it was actually zero. And that's what they did. And they lied and told the whole world in 1887, or not 1887, that's when they did it. It was like the years after that they told everybody. But they told everybody that they measured zero and that there's no ether is the reason why they measured zero. And in reality, they measured, if me and you were to go out, RL, and I was to take some kind of speed meter and measure how fast the wind's blowing, and, it measured 150 miles an hour, that's nowhere close to zero. You'd be retarded to say it was zero. Imagine how much more retarded it is to say that 15,000 miles an hour is zero.
My question still stands.
Well, it means the solar system that they've built is a lie, and if that's a lie, everything step by step that comes from that's connected to that, because if that becomes a lie, it's like a bridge. There's a whole city built on top of a bridge. But if it's a lie, the bridge breaks, the whole city falls down.
He doesn't care, Piezo. Listen to him. He doesn't care. He's not listening.
I am listening. That's not my question. You repeated yourself 14 times. My question is, which you didn't answer, I guess you might not have heard it, but what about space? What about the current situation above space, above the ground or whatever in space, do you think is not real? Because ether exists.
The distances, the velocities, all of it. All we have is empirical observation. We watch something complete a circuit in the sky. We ratio that against pi, and we get a physical circumference, right? That it shows that none of that ratio is not real. It doesn't have any physical meaning. It is a ratio. You can calculate it. That planet will definitely be back, at the corresponding time that would, if it was traveling that distance at that speed. But it shows that has no relevance to where it actually is in three-dimensional reality.
So let me be more specific.
Space, let me tell you this, space is fake and
decay. It's not
decay.
required to be more specific. We got it, dude.
It is because you're telling just the point of my question. You believe the physical objects are up there, satellites, spaceships, rovers on Mars. You just think they're lying about
not rovers
numbers?
on Mars.
There's no rover on Mars. Satellites, I would grant you, on the stipulation that they could be closer and moving slower, you wouldn't know. That's it. Because they follow Kepler's laws, that same ratio relationship. So if they're closer and slower, it would be the same thing.
The moon?
What about
the moon?
Oh yeah, no one's been to the moon.
I didn't ask that. I said, is it in space?
I mean, whatever you consider space, it's in the heavens. Whatever.
I'm asking you. How far away is the moon?
I have no idea. Depending on different assumptions that you make, you can do triangulation to get different distances. Same with the sun, the moon, because they're basically the same size. So,
but not a 250,000 or 93 million or anything like that miles away.
Gotcha. What about the ISS? Is the ISS up there?
Same situation with GPS satellites. It could be closer, moving slower, whatever it is, and you wouldn't know.
Okay, so is the ISS in between the Earth and the moon?
Yes, it's nowhere near the height of the moon, dude. Yes.
I didn't ask about the distances. I'm just asking, does it go to the moon in terms of distance from the Earth? Is it Earth, ISS, and the moon?
Yes, they say even in your model or the mainstream model. I don't know what model you use, but the mainstream model says the ISS is 250 miles and the moon is 250,000 miles. So yes, the moon is much further away.
I'm just getting to some basics, some things that we can agree on and things that we don't agree on. Again, throw the distances out because if the ether exists, the distances are lies. I agree with you on that. I'm just trying to figure out
there's still a scale. There's still a scale, bro. Like the only thing that will stay is like scales and ratios. Absolute numbers will no longer be true. But the point we're making, right? The point we're making is like it doesn't in our model, in their model, in anybody's model. The scales and ratios are all the same, but the absolute numbers would be different. And the problem in reality is they have to say that the absolute numbers that they've come up with are real, because otherwise everything they've told us is a lie. They didn't go to the moon. They didn't go to Mars. They didn't send probes out past Pluto. None of that's real, because if the absolute numbers are wrong, then all of that's fake.
So, like I said, and this is a complete opinion. It's your opinion. I can't say you're right or wrong. So you're saying that tomorrow the newspapers come out, ether is real. We've been doing the calculations wrong. Everything's still a go. Voyager 1 is still out there. We just calculated it different. It's not 2 billion miles. It's actually 1.5 kilometers away. Like that's what you're saying.
Do you really think that makes any sense, dude? If I told you that Africa was 4,000 miles away and then you traveled 500 miles, do you think you'd get there?
For the missions that they've claimed to have accomplished to have been done, they would have had to have been done by the calculations they're already telling us. So for the ether to exist, then that's all fake.
Yeah, if I told you, hey, from your house to my house, it's 400 miles, just drive down this one road, it's a straight line there, go 400 miles straight here, and you'll get here. If you drove 15 miles, do you think you'd make it to my house?
Of course not. You just skipped right past my question. I'm asking if science agreed that Aether is real tomorrow, and then they said, you don't think they'll say, your answer is no, but you don't think they're going to say, oh, we did our calculations wrong, these numbers are off, oops, we messed up. Let's still go. Let's go. Everything's still the same. You don't think they'll say that, right?
No, that would be a fundamental violation of logic and common sense.
Dude, they're claiming to have gone with certain distances. It doesn't make. I don't understand what you're not getting.
I'm done with this conversation thread. There's too much time been wasted on it. It was good for the rest of the audience, but like I'm done at this juncture, bro. There's no point.
If they admit that Aether is real, then they've been lying, and nothing else as far as deep exploration of space is real. I get it.
All right. Y'all have a good day, and
Later, Piezo.
peace.